So we have come to the next chapter, that is working principle and testing of passive and active components. Now we'll come to the next topic, that is capacitor. Okay, it is denoted by a capital letter C, or it is denoted by C. Okay, now what is the working principle of a capacitor? What does it do? There are two plates. In between there is a gap. That gap we call it as dielectric gap or dielectric material. In this material, the charge is stored, right? The electrical charge, because when you give positive and negative to the plates, one side positive, one side negative, then the charge is produced and the charge is stored in this. That is the main working principle of the capacitor. With this charge or discharge principle, we can do a lot of work. The capacitors can do a lot of work in the circuit. Okay, so that is the very important part. That is an electric device consisting of two conducting plates separated by an electric insulator, or we call it as a dielectric material, designed to hold the electric charge, right? Designed to hold the electrical charge. All right, now we'll go to the second slide. You will find different values of capacitor. Please remember, farad stands to 1, that is 10 to the power of 0. You will get maximum capacitor in the market, or you will see in the companies or factories or in the circuits, which will be in microfarad, nanofarad, and picofarad. You will never find a capacitor with kilofarads. So farads, microfarad, nanofarad, picofarad. What is the difference? Micro, it is written in mu. Mu is microfarad. That stands to the 10 to the power of -6. That is, before decimal, it is 6 points. Okay. And nanofarads, it is 10 to the power of -9. And whereas picofarad, it is 10 to the power of -12, sorry. Okay. So you can just find it out. This small thing, you have to keep it in mind. Types of capacitors, two type, fixed value and variable. Again, like resistor, you have two type of capacitors, fixed value and variable. Okay, right? So you have fixed value capacitor with two terminals. In there also you have so many categories, polarized and non-polarized. Non-polarized, maximum it will be of polypropylene capacitor, metallized polypropylene capacitor, ceramic capacitor. Whereas non-polarized, it will be a gel, a special type of material is used for storing the energy for a longer period. Okay, which will have a compulsory, which will be having a polarity that is negative and positive. It will be written on that particular capacitor. So polarized and non-polarized capacitor. So tantalum, there is one kind of capacitor which is used, that is called as tantalum capacitor. It is also an electrolytic capacitor, but with a very low value, right? The microfarad value will be very, very less. Variable capacitor, you can see here two types, trimmer capacitor, gang capacitor. You can see the difference between the trimmer capacitor symbol and the gang capacitor symbol. Here, trimmer capacitor, it has a T type of symbol in between, whereas gang capacitor, you will find two capacitor with the arrow and it is joined together. The gang capacitors are the tuning capacitors. We call it as a tune. For tuning purpose, to change the frequency, we use this. Of course, trimmers also used for changing purpose, but the frequency range will be little lesser. Okay, work is same for tuning purpose. So capacitors, two type, trimmer capacitors and gang capacitors. All right, capacitor in parallel. What happens in the to the value? Capacitor, if it is in parallel, exactly reverse of your resistor. Please remember, when it is connected in parallel, the resistance will be divided. Whereas in capacitor, it will be added, exactly reverse. Okay, that point you have to remember. Okay, capacitor in series, what happened? It will be added. The capacitance will be added. It will be in series, it will be divided. The value will be lesser. In the case of a resistor, it was added. That means the value will be higher. This one, you see, R1 plus R2 plus R3. Here it will be 1 by C1 plus 1 by C2 plus 1 by C3. It will be divided. So I hope you understood this. I will show you the practical. All right, friends and students, you can see in this circuit, I've connected few of the capacitors. Okay. And you see one LED, it's glowing because it is connected to the battery. So this direct, the supply is going to this thing. At the same time, what is happening? Positive and negative, it is also connected to this capacitor. Okay. This particular capacitor, this is also connected. So you can see that it is directly going. Now what happens? You just notice it. I'm removing the one supply from it. So what happens? You just please notice it. I've removed the supply. You can see the LED is going slowly. It is coming, switching off, or rather it is dimming around. Okay. Once again, I will try to show it to you. I'm just putting it again, and you can see I'm just removing it. Slowly it is going. This thing. What does it mean? I told you the properties of capacitor. This will store energy inside for some time. That energy is released to the LED, and LED slowly gets the capacitor get discharged, and the energy is released to this. That light in the form of a light, you can see slowly it is going. Then it will become to zero. When you charge it again, it will hold the charge. That is charging and discharging principle. Okay. Now you can see this two capacitor here have connected in series, and this two capacitor have connected in parallel. This is electrolytic capacitor. When you connect an electrolytic capacitor, please remember positive to negative. Then again, next capacitor is coming in series, then negative to positive. Likewise, you don't have to connect negative, negative. Okay. Usually negative, positive, negative, positive. Okay. So this doesn't have polarity, so you can connect in any form. What happens? The main problem. What happens when it is the capacitor is connected in series and in parallel? Right? According to the formula, it is exactly reverse or opposite to the resistance formula. That is, when it is connected in series, it will be divided. Okay, the value will get divided 1 by R, 1 by C1, 1 by C2. Okay, when it is connected in parallel, the value is added. Okay, value is added. It was the just reverse the case in the resistor. All right, so you understand. One more thing I would like to tell you: you put the resistance in this to 2K. I will just show you how to test a capacitor. Okay. So I'm just holding this. You can see, just see in the meter what happens. Some values has increased and immediately it went away. Okay. Some value has come and immediately it went away. I'm connecting it again. You just check. There is a value, very value. What does it indicate? Charging and discharging. Okay. And this will also show you the capacity, the capacitor is working okay or not. One more thing I would like to tell you. In electrolytic capacitor, on the top, this surface, right? This is it should be flat surface. It should be flat surface. If the surface gets swollen up, please replace the capacitor. Please replace the capacitor. The capacitor has gone bad. In this case of this capacitor, that is PF or ceramic capacitor, if it is shows short means what? If it is just short means what? If you connect these two, if you are getting this value, that is 0, we call it as a short, right? It should not show anything like this. So we say the capacitor is good. Okay. Please remember, in capacitor maximum time, either it will get short or either it will get open with the help of a multimeter, not the LCR meter, because I don't have LCR meter, so I cannot show it to you. So LCR meter, you can correctly find the value, whether the value is correct or not. But testing of capacitor, I just now shown it to you.